Welcome everybody. I would like to give some special hints to you for tomorrow's lab quiz. You will be given a circuit like this. So you will be given a circuit like this that will include a voltage source, AC voltage source, a black box, a sense resistor, so let's say for this particular example I assume the sense resistor is 2 ohms. We have a black box and the input voltage, let's say we have an expression like 100 sine 10t plus 0 degrees. So my voltage source got 100 sine 10t plus 0 degrees. In frequency domain you can write the voltage is 100 0 and the frequency is 10 hertz. And for this particular voltage and the sense resistor black box for this particular circuit we connect our oscilloscope channel 1. This is my channel 1 and we connect my oscilloscope channel 2 here. So this channel 1 measure the voltage across the source. So this channel 1 positive terminal will be connected here and negative terminal will be here, so you get the voltage. And for channel 2 the positive terminal will be here and negative terminal here, so you will get the voltage across the sense resistor. And from these two wave shapes, like the voltage for across the source and voltage across the sense resistor, you have to determine the circuit configuration of the black box and also the value of the black box component. So let me see what type of wave shapes we get from this. So we got a wave shape for omega equal to 10 hertz. We got a wave shape like this. So this is my channel 1 wave shape. So channel 1 and this is for channel 2. Channel 2. So now channel 1 is the voltage of the source. So you can write the voltage for the source. So this is the source voltage. So the voltage for source expression, you see the maximum voltage is 10. So you got 10. So let's say it is also told that channel 1 has a settings for 10 volt per division and channel 2 got a setting for 1 volt per division. So channel 1 has a setting for 10 volt and you see here 10 volt, and for each volt has 10 volt per division, so it will be 100 volt in total and the phase angle is 0 degree. Now for the sense resistor voltage or the channel 2 voltage VR, so it got, you see here 7.2 and 1 volt per division, so it will be 7.2 and voltage is 1 volt per division, so 7.2 volt. Now find the angles from here. So you see we have total 32 divisions from here to here, so you have total 32 divisions and each division got 11.25 degrees. So 1, 2, 3, 4, 5. So 5.6. Let's say we got 5.6. So let's say from here to here, I got the angle is 4. So let's say I got the angle is 64.3. So you might get an approximate value. I got the exact value 64.3, but you might choose a approximate value from here. So you see here the 90 degrees is over this point. This point is 90 degrees. So each division got 90 divided by 1, 2, 3, 4, 5, 6, 7, 8. So 90 divided by 8 for each division. And you see 5, and this is 5.6 or 5.65. So I got 64.3 degrees. This is my sense resistor voltage. So now I can find the current in the sense resistor. So sense resistor current will be sense resistor voltage over the value of this resistance. So you will get 3.6 and angle will be 64.3 degrees. So I write 3.6, 64.3. This is IR. So now I got the voltage expression from this graph and the current expression from this graph. Now we can easily compute the impedance. So impedance is voltage over the current. So we got the source voltage over the total current IR. As it is series circuit, you see the circuit, given circuit, the box is in series with the sense resistor. So we can write the current in resistor will be the current through the box. So we can find the Z. And from here we also can determine what type of configuration we have. You see the voltage angle is 0 degrees and current angle is 63. So current got higher angle than voltage. So current negative. So here we got current negative, current fall, current. So we say current lags the voltage. So it will be RL circuit. So now I got the circuit is RL circuit, resistance and inductance circuit. So you can find RL circuit from this configuration. So as you see, the voltage is graph. This is the voltage graph. This is the current graph. Voltage graph is leading the current graph. So it is RL circuit. So voltage leads current, or current lags the voltage. So it is RL circuit. Now we have to know what type of, how the R and L are connected in this. And to get that, or to realize how their connections inside the black box, you need to vary the frequency. So this graph was found for omega equal to 10 hertz. Now if I change this frequency, let's say I change the frequency to 20 hertz. So this is for 20 hertz, omega equal to 20 hertz. This is my channel 1 graph, and this is my channel 2 graph. So from this 20 hertz, you see the phase angle is now this much. So this is my phase angle. So phase angle has, so you see the phase angle now, it has 1, 2, 3, 4, 5, 6 and 6.6. So phase angle will be, phase difference is 76.5. So we got 76.5. Now you see, if we increase the frequency, the phase difference increases. So current now, so this angle between voltage and current now increases. So before, the phase angle was, this phase was 64.3. Now it goes to 76.5. So as the phase angle increases, so we can see, so we can conclude that, so at first we found that current lags voltage, so RL series, RL network. Now we see the frequency and phase relation. If frequency 10 Hertz, the phase was 64.3, and if the frequency is 20 Hertz, the phase becomes 76.5. So we increase the frequency and that increase the phase difference. So that means RL series. So we get the information that current lags, that means RL. Then we change the frequency and see the response in wave shape. So we found that voltage and current, so this current phase angle change as we change the frequency. So it is RL series circuit. Now we need to find the value of R and L. So to find this, you can either pick 20 Hertz wave, or you can say the 10 Hertz wave. So let me see the 10 Hertz wave, and that we got the magnitude of 10 Hertz is 100, 0 degree, that's from channel 1. And from channel 2 we got current equal to 3.6, angle 63, angle negative 64.3. So it is negative, this is negative. So phase difference, phase difference. So now if you see the current and voltage, so you can find the impedance equal to voltage over current, that is 100 0 over 3.6 angle 64.3. So from here you will get, so that gives us, let me find in polar form, so that gives us 27.77, and shift angle is 64.3 degree. And if I convert to the rectangular form, it becomes 12 plus angle is 25. Now we have this total impedance. So total impedance ZT will be the box impedance resistance plus box reactance plus the sense resistance. So total is 12 plus J25. So R box and X box is 25 and R sense equal to 2. So you see that the resistance of box will be 12 minus 2, so 10 ohms, and the X box, the impedance of box is equal to 25 ohms. So as you see, we solve it for omega equal to 10. The L will be x is equal to omega L. So L will be x over omega. So 25 over omega equal to 10. So 2.5, and we got a wave shape for our another wave shape where this is my channel 1 and this is channel 2, channel 1 and channel 2, and this is was for omega equal to 20 hertz, and this wave shapes was obtained for omega equal to 20 hertz. So now for omega equal to 20 hertz we got this wave shape. So this is channel 1 and channel 2 and this. So here the channel 1 basically the voltage and channel 2 basically the voltage across sense resistor and voltage across the source. So as you see, the voltage across the sense resistor is equivalent to current. So basically this is current. So now we have current and voltage. So here you see current leads the voltage. So current leads the voltage. So you can write current leads the voltage. So therefore it will be RC circuit. So we got RC circuit. Now if we change the frequency, let's say we change the frequency and come up with this. So we do it for 100 omega equal to 10 hertz, and we got this is my source voltage and this is my current. So this source voltage and this is my current. So here you see what is the angle of this between voltage and current, the phase angle. So the voltage and current, the phase angle, let's say we got phase angle equal to 64.3 degrees here, and for this graph we got 74.5 degree here, 76.5 degree here, and we got 64.3 degree here. So this is 64.3 degree for omega equal to 20 hertz, 63.4, and for omega equal to 10 hertz we got 76.5. So just now if you look at the frequency sense, so for omega equal to 10 hertz our phase was 76.5 degree, and omega equal to 20 hertz it becomes 63.4 degree, 64.3 degree. Now you see if you increase omega, phase decreases, so it becomes RC, as we found RC before. Now it becomes RC series. So for RL series you found that if omega increase, frequency phase angle increase. Now here if so we don't look at the angle, we don't look at the sign of the phase angle, just we look the difference. So before the difference was for current, you see RL circuit, for RL circuit we got the difference was 64 to 76. At 10 it was 64, now it is 76. Now here the difference is 76 was for 10 hertz and it becomes 64 for 20 hertz. So it is RC series. Now if you want to get the value for this, so So we can choose either RC10 or RC20. So for RC10, for 10 hertz we got, so for 10 hertz we got, this is my source voltage. Let's say this is source voltage is from here. Let me say we found this value. You will be given this value clearly on the graph. So you'll find this value. Let's say we got it 100 volt, and from here to here we find the voltage from here to here is equal to 3.89 volt. So 100 volt and 3.89 volt. So for V source we got 100, 0 degrees. We always assume V source as reference. So this is my reference. And then we found VR, that is 3.89, and angle is, so now it is positive. It started earlier, so it will be positive 76.5 degree. So now from here you can find IR. IR will be VR over 2. So you see 3.89. So it will be 1.944, angle 76.5. Now if you want to find the impedance, impedance will be 100 over 1.944, angle 76.5. So you'll get 51.419 minus 76.5. So if you find the polar form, rectangular form, it will get J50 approximately. So you see the total resistance is 12. So it got box resistance plus the sense resistance. So R box will be 12 minus 2. So 10 ohms, and XC equal to 50 for omega equal to 20 hertz. Sorry, omega equal to 10 hertz. So you can write C equal to, so XC equal to basically 1 over omega C. So C will be 1 over omega times 50. So 100 over 500. So it will be 2 millifarads. So this is how we can find the unknown value for resistance and capacitance. So at first you need to look at the wave shapes. So if the current leading, that means capacitive circuit. If current lagging, that means inductive circuit. Then you have to look at the frequency. If the frequency increase causes the phase angle increase, then it will be RC series circuit. Decrease, then it will be RC series. If the frequency increase causes the phase angle to increase, then it will be RL series. So now for parallel circuit, so let's say for, this is for RL. So you see here channel 1, let's say this is voltage, and channel 2, let's say this is current. Now for channel 1 you got voltage leading, current lagging. So this will be RL circuit. And we got it for omega equal to 10 hertz. Now we got the another wave for omega equal to 20 hertz. So if you look at this, this is my voltage and this is current. And from this current you see the phase angle now smaller than this. So this is the 1, this is 2. So omega 1 and gives phi 1, omega 2 gives phi 2. Omega 2 is higher than omega 1, but phi 1 is higher than phi 2. So that means if you increase the frequency, the angle decreases. So if you increase frequency, increase in frequency, decreases the phase difference. So it will be RL parallel. RL parallel. Now if you want to find what will be the value for RL parallel, so let's say we have a black box now, and this is the sense resistor, and this is my source. So we found the channel 1 here and channel 2 here, and let us assume the channel 1 at 10 Hertz got the frequency equal to channel 1 has the voltage V like previous 100 volt 0 degrees from channel 1, and channel 2 gives us VR equal to 8.955 and angle gives us negative 17.98 degree for channel 2. So let us got this from this wave shape. So this voltage, maximum voltage is 8.9 negative 17.98 degrees. Now we can find IR will be 8.955 minus 17.98 divided by 2, and you will get, we got 2 times 8.99. So IR we got 8.99 times 995 this. So this is my IR. So from this IR you can find Z. Z will be VR over IR. So VR over IR, so you get 100 0, and IR is 8.955 times negative angle of negative 17.98. So you will get the impedance of 11.166 angle 17.98. Now from this you will get 10.62 plus J of 3.44. So this is, as you know, we found this is RL series, RL parallel. So we found my circuit will be RL parallel like this. So my black box is RL, and this is my sense resistor, and this is my source. So you got your channel 2 here and channel 1 here. So this is R box, and this is X box, and this is R sense. So we got Z equal to this. So this is my R and X. This is my X. Sorry, you can subtract 2 ohms from here. Yeah. So you can you can subtract 2 ohms. So you'll get the impedance of box will be 8.62. I subtract 2 ohms from here. This is the sense, because total, this is the total resistive value and total inductive value. So if I subtract 2 ohms, they will get the resistive value for the box plus J of 3.44. Now you got the impedance of this part is this. Now you need to find R and X. They are in series, they are in parallel. So this is not the, now the combination here shows my series, but you will get here the parallel. So what you have to do, you have to inverse this. So inverse this value. So 1 over 862 plus J 3.44. So you have to invert this, and if you invert this on board Z box, you will get Y box. So y box will be 0.1 minus j of 0.04. If I do it like 8.62 plus 3 point, sorry, I put in brackets, so 8.62 plus 3.44 I inverse. So gives us 1 minus j4. So this is my, now this is my 1 over r box. 1 over r box is 1.01 and 1 over x box is equal to 1 over negative j 0.04. So you can find r box is 10 and x box is equal to 25, j25. Now once you get x box, you can find L equal to omega L equal to j25. So L will be j, sorry, not j, you can write omega equal to 25. So L equal to 25 over the frequency is 10, so 2.5 in this. So this is how we can find the value for unknown impedance. Sorry, you can value for unknown resistance and inductance. Similarly, you can practice for RC circuit, RC parallel circuit. So I show you how to solve for RL parallel circuit. So you have to get the voltage from channel 1 and the voltage from channel 2, then find the current from channel 2, then find the impedance. This is the total impedance including the sense resistor. Then if you exclude or subtract the sense resistor, you get the box impedance. Now this box is basically the parallel combination of resistance and inductance. So I inverse it. So I take the opposite of this and find y box. So once you get y box, now y box, this is the conductance, and this is the susceptance or inverse of reactance, and this is the inverse of resistance. Now if you again inverse this, you will get the resistance of the box, and inverse this, you will get the reactance of the box. And from this reactance, you can easily find the value for unknown impedance or box impedance. Hope you a good exam. Thank you.